This meeting is being recorded.
All right, Felienne.
Great. Are you all seeing my slides?
Yeah, let me just introduce you for the recording, I guess. So this is the Lang team meeting. We've got Felienne Hermans going to talk to us about the psychology of programming. Take it away.
Yes, hello everyone. My name is Felienne Hermans. I'm an associate professor at Leiden University in the Netherlands. And what I'm presenting today is actually part of my course. So my course, it's a grad level course. It's called Psychology of Programming. At first I thought, I make the slide something different for you. But then I thought, why not show the lecture as I usually do it in class? So that can be fun. And the goal of this lecture is to help you all think about how to make decisions on programming language design. That's also a big part of what the course is about. So these are my actual lecture slides that I use. For the students, I say active participation is required. And I think this would also be fun if there's active participation from you all. And you don't have to use your voice or your video if you don't want to. But if you do want to share things, you can put them in the chat. I also have the chat in view so I can see what you're doing. And to make participation a little bit more fun, I actually have the participation panda, which I also use in class. So whenever there's a panda on the screen, this means you have to do something or think about something to keep it a little bit active. And we will immediately start with the first panda exercise. So feel free to type the answers in the chat. Given that I have two programming languages, A and B, and you may also, of course, think of this as Rust version 1 and Rust version 2. So it doesn't necessarily have to be two entirely different programming languages. It can also be versions of one programming language. What would be a way to study which version is better? Just type your answers in the chat. I will read out some of the answers in the chat that are worth it. Someone is saying spending 10 years to get good at both of them and then make your own comparison. Ask users is what someone is saying. Let's see what we get. Look for code that is similar and compare this to see how simple it is. See which helps people write programs faster without with fewer bugs. What are you doing the language for? Which language catches more issues? Very, very cool. Already quite a wide variety of things that you could do if you wanted to compare two languages. And as I said, that's really the goal of this talk, to give you a wide vocabulary of things you can try if you want to compare different languages with each other. So my guess is, and this is mainly a guess that I use for the students, is that something that people would say is doing experiments, trying out experiments. This is specifically true for our students. This is a fun statue that's in front of our old university building. It is in Dutch, but the sentence here says, by measuring, we get to knowing. So if we measure things, we will learn things. And this is in front of our building. And that's interesting because, of course, this gives a certain research philosophy, actually, right? We can only know things by measuring things. And that's very much the frame of thinking that I see with my students, but also with people that I interact with in the PL community. Very often people want to get to numerical values, they want to measure something, because we've sort of all grown up with this idea that science is about numbers and that it is possible to measure things, right? If you went to high school in most countries, probably you are familiar with scientific methods. This is what we see as science, right? The natural sciences, where there's a stage that is observation, something happens in the real world, and then you form a theory, which may have the form of letters or words, but it can also be letters and formulas. And then if you have an observation and a theory, you must have a hypothesis, like this apple will fall. And then if you have a hypothesis, you can do an experiment. That's more or less what we see as the scientific method. And sort of whether we like it or not, that is a frame that we often think about if we think of we want to gain more knowledge, even if we want to gain more knowledge is about programming language design. So the goal sort of today is that I'm assuming you are familiar with this way of doing research. And it's my idea to give you also additional ways that you can also use to make decisions based on science that aren't necessarily measurements and experiments. So let's go into the scientific method and science a little bit more deeply. We typically divide science in different forms or different ways of doing science. First, we have the natural sciences, which is studying nature, studying things that exist in the real world. But we can also study people. We also have the social sciences, in which we are studying people and their behavior. And then there's also humanities, and humanities means usually studying the things that people produce, artifacts like archaeology, but also books and music, studying what people create. That is also a way of doing science. And this scientific method very much fits with the natural sciences. That's a good fit, because the world, it is as it is, whether we like it or not, there is gravity, right? So we don't have much control over exactly how the world looks like and works. So then it fits that we are trying to measure things to gain an understanding. So it very nicely fits here. But the social sciences don't really fit. And then you already have to make some changes. Often we do this in medicine, for example. We don't do actual experiments because people might know that they're in experiment and then they start behaving differently. That's not true for magnetic fields or particles, but that is true for people. So then you have a controlled experiment. It sort of still fits the model, but a little bit less. But then if you're studying the things that people make, yeah, what kind of hypothesis is there? What kind of experiment can you do, right? If you're an archaeologist and you're gathering axes that are in the ground from a certain period, well, you look at it and you're like, oh, this looks like a thing people could use to chop trees with, right? There's not really an experiment that you can do there. You just observe, and then only from observations you will form a theory, and then that's the end sort of the science. So all these three things can play a role, and I would go as far as saying should play a role in informing the design of programming languages, but very often the first forms are more commonly used than the latter forms. So imagine we have two groups of people. Some people really like JavaScript and other people really like C#, and we want to understand which language is better, for whatever better means, right? There were good points in the chat, like what are people even building? But imagine we want to somehow compare these languages to inform the decision of yet another language, like Rust. So you can measure. There are numerical things that you can do to gain an understanding of these languages. But then an interesting question immediately becomes, okay, what are we measuring, right? So next participation panel, name some things that we could measure. Imagine we want to compare JavaScript and C# or other languages, doesn't really matter. What actually could we measure? So let's see what people are already typing in the chat. Yeah, that was really fast, Scott, well done. Length of programs, the lines of code, execution time can be measured, efficiency, errors, how many errors do people make? How pleasant is it to use the design? So you can ask people, what would you like? Nice. The joy of users, code goal, feedback, many things already, many numerical things that we can find. The community size, existing library size of the ecosystem. Also really good suggestions of numerical values that we could compare. So one of the things that people often think about, also what some of you thought about in the chat, is performance, benchmarking. I think this is one of the most common ways. If you look at POPL papers, for example, scientific papers about programming language design, very often there will be benchmarking. Say, look, we implemented it such and such way, and now we shaved off 1 minute of compilation time or 1 minute of execution time under certain conditions. Interestingly enough, this is an accepted measure of okayness, of goodness, right? So look, this is 1 second, this is 3 seconds. Well, this is quicker. That's sort of agreed upon that quicker is better. But there's also other measurements. Someone also mentioned this in the chat, lines of code, right? Shorter. And then with shorter, it's already doubtful whether it's better, right? Yes, in general, we like short code, but it's not always so clear-cut that short is better than long. Because, for example, if we look at Game of Life, probably familiar to many of you, a simulation with cells as you see visualized here. This is an implementation of Game of Life that's done in C. If you scroll, this is like 200 lines of C code. And if you execute this, C++, it's not even that exciting, right? You just get strings in the command line. It's not even very nice. You can compare this with APL. This is also game of life in APL. And this final line is the entire program. And then I even get this really, really nice visualization. But now I have 200 lines of C++, or I have 1 line of APL. Yeah, you know, it is shorter really better. I'm not sure if I agree that I would prefer to maintain this 1 line of APL rather than the 200 lines of C++. So with short and long, it is sort of in the eye of the beholder, and it very much depends on your preference. I'm going to say, yeah, I would rather maintain the 200 lines of C++. Yeah, I guess me too. So with shorter, already taste, you know, starts to play a role. What actually do we like? What do we prefer? Are we typing it? Are we maintaining it? Those are different questions. What we could also do, and what people also said in the chat, hey, we could ask people, for sure. We could just get random people, programmers from the internet, and say, hey, what do you prefer, right? And then people might say, well, I prefer JavaScript, I prefer C. Some people might say, I don't prefer either of them, something else. And then we can count what the preference is. However, as soon as people get involved, very often, this is the moment where people start to talk about sample sizes and sample bias. Yes, but who have we asked? Was this survey not only posted on the JavaScript website, right? And that's already interesting, I think, because also if you're benchmarking, clearly there's selection bias. Which algorithms are you benchmarking? Which machines, which CPUs and GPUs are you using? But it is my experience that whenever people are in the picture, this becomes a bigger thing than when it's still machines, even though clearly in any selection, including benchmarking, there is always selection bias. So to dive a little bit deeper in these different types of research that you can do, and that we also do in computer science and programming language design, we can measure speed, we can measure lines of code, and we can ask for opinions. And all these things are what we call quantitative ways of doing research, because the ultimate result is a quantity, is a number. So we measure how many people prefer C++ or C over JavaScript. We're looking for a numerical value, and that's always quantitative research. And it sort of feels like science because it has numbers. What we can also do, rather than saying which one do you prefer, is how do you like this language? Someone also said this in the chat, like we can measure the joy of people using the language. So we can say, hey, how do you feel about C#? And also, how do you feel about JavaScript? And then you have people give open text answers like, oh, well, I don't really like JavaScript. Oh, well, I rather eat stones than program JavaScript. I hate it. It is horrible. And then from such open text, you could also draw conclusions. For example, well, more people like C#. So here's another banana question. If I ask people, how do you feel about JavaScript? And I look at what the answers is compared to how they feel for C#. Would you say this is quantitative? So are we here ultimately looking for a number, or are we doing something else? Simple yes or no in the chat would be okay for this. Depends on the question. Interesting answers in the chat. So some people are saying sort of it depends on the question. So I would say it much more depends on the way of analysis than it does on the question. So even with this question, I can analyze this question in a numerical way, because I can give a rating, right? I can see, well, okay, it's neutral, hate it, it's negative. I can do sentiment analysis, for example, on the answers. I can get this data into a numerical form. So it is somewhat quantitative if I want to get this data in a numerical form, but I can also do something else with it, like learn from it, observe from the data. So I would say it is definitely possible to get this data into a numerical form, and therefore it can be quantitative. I also very much like Josh's answer. He says we could also write code and look at people interacting with the code. This is very, very much also a way we can do research, and we will get to that type of research a little bit later as well. So here I would say we could count these numbers, so it's still quantitative, but we could also get sort of more and more away from quantitative research. Because I could also ask people, why do you like JavaScript? What are the things about JavaScript that you very much like? And then I get really different answers, right? I get all sorts of answers. Maybe people like JavaScript because my friends also like JavaScript. So it's a community thing. Or maybe people like it because it doesn't have a compiler, so it's easier to use. This data is harder to get in a numerical form. Now, there's not an easy way I can make this into numbers, even if I wanted to. That type of research we typically call qualitative research. So it's not really about quality, it's more about understanding the aspects of something, understanding the qualities that something has. So something like asking opinions can be quantitative, but can also be qualitative. And other things, this is a bit, I think, what Josh was referring to. We could also study what people's experiences are. We could do over-the-shoulder studies where you really look in someone's screens. You can have think aloud studies where people tell you what they like or dislike about something. And a study that's also quite interesting, and it has not been used so much in PL design, is you can also do diary studies in which you, for example, send people a push message every day at 2 p.m. and you ask them, hey, programmer, how's your day been so far? And you just let them write down little snippets about like one problem that you encountered today, one good experience that you had with your programming language today. And if you do that over a longer period of time, you can definitely gain insights in the type of things that people like or the type of things that people struggle with in a way that's really different, that might not, like small things that might not come up in an interview. Or you could also ask opinions not in a survey, but in an interview, which is also, again, different. Because in a survey, people write stuff down. And in an interview, you can really go back and forth, like, oh, tell me more about this. Oh, do a little bit more of that. So these are types of research that are typically seen as qualitative because we're not aiming to get to a number. We're aiming to get to an understanding. Because one of the things I see people that do PL design misunderstand is that they're like, oh, but if we have version A and version B of the language and we measure which one is better, then we know what is better. But very often we're not only interested in which one is better, but also in why it is better. Right? Imagine I do a hypothetical experiment and C# programmers are, I don't know, 0.5% happier than Java programmers. Suppose I can measure this imperfection. Why, right? How does this help Rust design? What part of C# can I take that I need to put in Rust? You can get that type of understanding from numerical data only. For example, one of the papers I myself did, I looked at block-based visual programming interfaces compared with textual interfaces. And one of the findings, for example, that we found is that if people work in a block-like language like Scratch, then what they like is that they have this canvas in which they can place stuff, right? This is a thing that people appreciate from such an interface. That doesn't make it good or bad. It just is a quality that such an interface has over another one. You might wonder, okay, so we will do some open text data, right? We can ask Rust people what they like, but now what, right? What do you do with this type of data? Now I have this data, what do I do? Typically what people do with this type of data is they categorize the data, which is called thematic analysis. For example, if you look at this tiny example, you can see that some people talk about technical aspects of JavaScript and other people talk about social aspects of programming language design, which is also very important. Like there might be reasons that you're interested in programming Haskell that have nothing to do with Haskell itself, but that have maybe to do with the type of status that Haskell might give you, which JavaScript might not, right? So that's a way you can classify this data, and you can dive deeper and make subcategories as well. For example, here you can say that there are technical aspects that really concern the language, like, oh, you can do functional programming, but there are also technical aspects that really concern the environment, like where do I program and how do I program JavaScript? This is what people do if you're an expert, if you do this type of research and you look at the data and you say, oh, I see a theme arising here. Oh, there's a bit of this and a bit of that. And then sometimes you do multiple rounds of interviews where you find 3 or 4 teams, and then you ask people to dive deeper a little bit in this. And this is not just random hand waving, right? This sounds a bit non-scientific, but it's just a different way of doing science. This is why I want you to be aware of these different types of streams. There are very, very clear methodologies to group these type of answers. It's not just that, oh, we randomly browse the answers and oh, it looks a little bit like this. You can do this in a more systematic way where you have different researchers classify independently and then compare notes and refine your methods. I also want to talk a little bit more about these different types of things we can look at, right? So far we've mainly looked at looking at people, asking people, interviewing, observing. So we're really doing social sciences research in a sense. We're looking at people and we're asking what their experiences are. But there's also this humanities research in which you look at artifacts. That is also a way of doing research that has not been that much adopted by programming language design, while it has been quite adopted in software engineering research, which is interesting. So the idea of doing this type of humanities research is that rather than manually reading 1 or 2 programs, which you could do, and I think even some of you also said that in the chat, like you could look at what people write. But if you do this with many programs in an automated way, in linguistics or in history, this is called corpus analysis, where you look at a corpus of data and then you look, how do people talk about certain things, right? How are women or men, for example, discussed differently in literature? You could do this by manually reading books, but you could also do this with a little bit of source code. And you can imagine that something like GitHub is actually very, very good at helping us make decisions on PL design based on what people have already created, which might be a little bit less biased because people might say, oh, I never use this feature, but they do, right? Maybe they don't know, they don't remember, they forgot about it, they don't want to share it. So here are just 2 examples of papers that do corpus analysis to look at programming patterns, potentially also to inform decision making. So here's a paper that I very much like that looks at code smells, right? Fowler's code smells like a long method or a big class. We sort of all know that code smells are bad, but is it really bad? So these researchers have looked at the Eclipse code base and they see that anti-patterns, which is the word that they use for code smells, that almost in all releases of Eclipse, anti-patterns, code smells correlate with lines of code being more change prone, more issue prone, and more exception prone than others. So they sort of prove, look, code smells are really bad because they actually correlate with errors in code, which might inform programming language design, because of course some programming languages might not allow for certain code smells to exist. And I have another example here. This is actually one of the papers where I am also a co-author. For this paper, we looked at Scratch, which is a visual language mainly used for children and for education. And we looked at what variable names do children use for variables and procedures. And just to show you an interesting piece of PL design, Scratch allows you to use spaces in variable names. So you see here, you create a variable with a little pop-up, and you see that the name of this variable has spaces in it. So it's number space of space jumps. This is, of course, an interesting choice because most textual languages will not allow you to actually put spaces in variable names for very obvious reasons. So we were curious, like, is this a feature that children like? Is this something that is useful to them? We could ask them, hey, do you like to put spaces there? But children might not even be aware that this is something special. If this is the only programming language they know, they'd be like, yeah, sure, right. Of course, why not? So we thought it would be super cool to actually look at what people do, what children do. And we saw that these spaces are very common. So 1 in 3 projects actually use a space in a variable name. And there's some other interesting things, like you can also use strings in certain places, and sometimes children would use round brackets, even though it's not necessary because there's no parsing going on. And this is a decision that could potentially inform programming language design, because yeah, I don't even know what the right answer here is. I am not the creator of Scratch. Like, do we want spaces here? It's very convenient, but then at one point kids go to Python or they go to Rust and the spaces are not allowed anymore. So maybe it is confusing. But here you see an example of looking at artifacts that kids have or programmers have created to get a sense of, hey, is this feature used or not? And in what way is it used? So this is a brief, well, not so very brief, sorry about that, a brief overview of types of research that you could do. So I hope that going forward, if you want to make more evidence-based or evidence-informed decisions about Rust design, that you think, hey, what am I doing? Do I need quantitative data? Do I want to understand how many people think this is confusing? Or do I want qualitative data? Hey, do I want to understand why is this confusing? Or what 3 or 4 competing ways could people interpret this piece of source code? So thinking about qualitative and quantitative. And I hope you also start to think about maybe the difference between what am I studying? What am I curious about? Am I curious about people's behavior that I can maybe measure with their code, or other things in GitHub as well? Now we're not just looking at code, you could also, as the previous paper did, look at, hey, what type of code creates an issue? What type of code is very likely to be changed in the future? GitHub is a bit richer than only looking at code. So sometimes you're curious about people's behavior that you can see also from GitHub, and sometimes you're really curious about people's opinions. Like, what do you think about this? Looking at this piece of syntax, like, does it give you joy? Does it make you happy? Those are just a few things about research methodology that might be useful going forward if you want to measure things. I'm seeing some questions. This is the end of my talk. Some questions already going in the chat, so feel free to drop your questions in there. We can totally spend the rest of the session doing some Q&A and also doing maybe some brainstorming on, are there open questions that you might want to think about? How can you experiment with this? Yes, so I'll start with the question.
I was going to say, why don't we take a few questions that are recorded and then we'll cut off the recording and chat open.
Yes, let's do that. So do you want me to look at the questions in the chat first?
Yeah.
Yes. For corpus analysis, are there existing tools that are commonly used? Yes, there are a lot of tools, but as I said, they mainly come from software engineering. So there are many tools that, for example, can extract your variable names or do smell detection, like what are the structural smells, like a long method. There are also tools that can do linguistic smells. For example, if you have a method that's called is valid, but it doesn't return a Boolean, it returns an integer, you probably want something that starts with is to return a Boolean. These are called linguistic smells. So those type of tools are very common. And also most of the tools that I know are meant for Java. Because that's just sort of the dominant thing that people have looked at. So there's some prior art, but I guess if we want to do this for Rust, we will also have to do a little bit of figuring stuff out for ourselves, because Java is not Rust.
Can I ask a follow-up question? In Java or any language, how much work has there been on developing like general purpose query languages? Like, I'm wondering if there's a design we can adapt to Rust. Because I
know there are generic things where you can read a Java code base and say, how many classes does this have? How many methods does this have? There are quite some tools that either print this out as a text file, or they give you a nice visualization of, oh, this is sort of the metrics, code metrics. So if that's the type of thing you're looking for, it's probably something is probably there, but those queries, as far as I know, are not. Like, you might want to do things like how many borrows, how many moves. Yeah, that's all Rust E. Same question, but for diary studies. Yeah, so that's cool, because I don't know. I only know of a few diary studies. One, this is my favorite diary study. It's very old. It's actually from Donald Knuth, the guy that made that was involved with LaTeX. He wrote a paper in which he logged all his own LaTeX errors for like 10 years. And that was the diary study, which was actually very, very cool, because it really gave a certain perspective. So that's an example I know, but I don't know so many. examples. Going forward to Felix's question, saying, hey, Git logs could be used as a proxy for diary studies. I like that idea. So there's, I don't know if that exists. I know there's lots and lots and lots of work in software engineering that's always very quantitative in nature. So that really tries to predict. I've done a bit of that work myself as well. Like if an image is in an issue report, is the issue closed quicker, right? That type of stuff. If a certain line of code has been changed many times, it is more likely that it will also be changed in the future. So for example, then you can predict which lines in this code base are likely to be changed in the future. But this is all very software engineering based on error proneness and never really, as far as I know, not so often used as a feedback into the programming language. It's usually as a feedback into the code base, like, oh, this part of your code base is smelly and you should make changes there. I don't know if that much work really that ties it back into programming languages. Sadly, the type of work that I do or that I want to do is not so commonly done. Most of if you read Popple papers, it's always like, hey, here's an algorithm and this is the benchmark. That's the research method that's really dominant in PL design. Somehow there isn't that much work that's really trying to do this human factor of PL design in mainstream PL. This is like why I'm here, where I'm trying to change that. Josh has a nice question. The last point that you are making, the trade-off between using one technology, Scratch, and providing good transfer to other languages, right? If you allow something in a certain language, should you also allow it in a different language? Such that it might make sense to not provide a feature in that it will negatively affect people's learning experience with future language learning yet. This is really, really a great question that I could talk for hours on, so I'll try to be brief. I think with every programming language that we're designing, we're always teaching two things. We're teaching the language and we're also teaching programming. So I do think to a certain extent, we all have a responsibility to design our languages in such a way that that you can reasonably expect to transfer to another language. Like one of the things about Rust that I am not so excited about, to give an example, is that we use a quotation mark in the triangle brackets, because typically this is a string. So if I look at this, my brain so often goes, oh, it's a string and it's not closed. Why is the string not closed? And I have to override that all the time because quotation mark means string in most places. So making such a decision, you can expect a little bit that it might interfere with other things. The same is true for choosing different similar words for very different things, or choosing very different words for similar things. So it's always interesting that the decisions that we make, you should expect people also to go to different languages. And I think the Scratch paper is a really interesting example where, as I said, I don't know what the right answer is. I think sort of my gut feeling says, why would you allow this? It will only make stuff worse later. But on the other hand, it doesn't have a parser, so why not take advantage of that? There are no easy answers here. Okay, great question from, I think, Scott. What is the best way to deal with familiarity impact? For example, the await conversation, I've anecdotally seen people that dislike postfix initially, but they've sort of warmed up to it. How could we know if the choice was worse than what we're seeing is survivorship bias, or if it's better? That is also a great question to which, sadly, there's not an easy answer. I guess this is almost, again, also a question of language philosophy, right? I think Rust is a type of language where we all say, well, it's not easy at first. It is really hard and it takes you a while to get it. It's like, I don't know, like a good wine or long distance running. You have to sort of stick with it for a while, and it takes a while to become good or fun. I think different languages have different opinions on whether or not that's a bad thing, but it's already good that you are aware that yes, there will be survivorship bias, that the people that like a certain feature is generally not everyone. The question of, is that a problem? You almost want to do something like exit interviews, like, hey, why did you give up Rust? And what was the straw that broke the camel's back. There is not an easy answer here that you can do, apart from, I think, being aware that this is a case. And I already talked a little bit with Josh and Sam. What's also very important if we're really talking about introducing a new feature is you have to figure out what you're worried about, right? So sometimes you're worried about people will not understand this feature and then they give up, right? If you don't understand the borrow checker, then Rust there is no path for you here. But sometimes you might also be aware, you might be worried about negative transfer, right? That, hey, we have await, but it's slightly different from JavaScript. We're not so much worried that people see this and they're like, what is this? What we're worried about is that people take their prior knowledge from JavaScript, which is slightly different, think that they understand this, and then make all sorts of horrible errors that they cannot then fix. That's a really different worry, right? Is this scary versus is this so similar to something else? So sometimes also if people sort of come to me and they're like, hey, can you help design an experiment? The first question is really, what are we worried about here? Are we worried that this is confusing? And are we worried that this is misleading? Those are already different types of answers. And I am sometimes not so very worried about confusing. Like if people have no clue what this means, they will probably Google it. I am maybe more worried about this being so similar to Rust in another place, Rust in another situation, or another programming language in a similar situation. But those are already different types of worry. And once you've nailed down what you're worried about, then you can also design a study on experiment where you can then ask people, hey, here's a piece of code. What do you expect this to do? And then you can measure whether the thing that you're worried about really occurs very often. And maybe even figure out, hey, do we have negative interaction more with Python programmers or with C programmers? So it is very much a matter of what do we think the problem might be and gaining more understanding about that.
Okay, sorry. I was going to say, I think at this point I'm going to end the recording. And thank you very much, Felienne. That was super great. And we'll put this up and then we'll chat a little bit after. Right? Or not bye. Bye to you who are watching the recording.